What lies beyond our Earth's atmosphere are numerous astrological phenomena. Through extensive research throughout numerous centuries, we have been able to observe and record what happens outside our solar system. One phenomenon is the supernova. Today, I will be discussing what supernovae are, how they form, and the effects they have on us and our world. Supernovae, as defined by NASA, are known as the explosion of a star. Every 10 seconds in our universe, a star dies and explodes into a supernova. They are the largest known explosion which occurs in space, and release approximately 10 to the 44th joules of energy per explosion, equivalent to the amount of energy our sun has produced in its entire lifetime. In fact, its brightness can be used as an indicator of distance within the universe. There are two distinct categories of supernovae based around their formation. Type 1 supernovae occur between two revolving stars, one of which being a white dwarf. Over time, the white dwarf absorbs energy from the other star, eventually reaching 1.4 solar mass, or 1.4 times the mass of our Sun. At this point, the white dwarf explodes, forming a supernova in its place. Alternatively, the white dwarf may collide with another star, causing supernova formation as well. Type 2 supernovae occur when a red supergiant star dies. Supergiant stars use the conversion of hydrogen to fuse elements. Heat is produced during this process, allowing outward forces to be pushed out and keeping the star stable. However, once the star burns through the last of its fuel and begins to cool, it collapses on top of itself, creating a supernova from the explosion. Before the invention of telescopes, there were numerous sightings of supernovae, the earliest of which was recorded by Chinese astronomers in 185 AD, of a supernova known as RCW86. It has been stated that it was visible in the sky for 8 months. Only 7 supernovae were recorded before the 17th century. The term supernova was not used until the 1930s, used by Walter Baade and Fritz Zwicky regarding the observation of what they called S Andronomae. This term is now used in our modern day to describe the collapse of a star. Supernovae occur towards the end of the star cycle. They are only present during the death of a supergiant star. The size of the supergiant is what dictates what will become after the supernova occurs. Supergiant stars that are roughly 8 to 25 solar mass will end up contracting into a neutron star after the explosion, which is a small, highly dense celestial object. Stars over 25 solar mass will instead collapse into a black hole instead, a place where gravity is so strong that not even light can escape its pull. Stars over 25 solar mass are usually shorter lived than those that are smaller. In the instance that a star is over 100 solar mass, nothing will remain after a supernova explosion. So, what are the effects? The explosion of a supernova does not only indicate the death of a star, rather, it also creates and spreads most of the elements that we have discovered, excluding hydrogen and helium. The creation of certain elements, however, cannot be drawn back to specific supernovae, rather, they are the product of numerous ones. Carbon, nitrogen, iron, and oxygen are all essential to life on Earth. Without these elements, life on Earth would be impossible. So, how does this tie into supernovae? Supernovae synthesize all elements heavier than iron, alongside creating carbon and nitrogen within the core while it was a star. The creation and dispersion of elements, ones that are crucial for allowing us to live and breathe, are formed through supernovae. This also allows for heavier elements such as tennessine to be documented. This process also alters how stars burn. Furthermore, supernovae enrich the interstellar medium, also known as the ISM, which is the space between stars. Supernovae explosions enrich the ISM with elements and cause the structure to become more complex. In fact, if one corner of the ISM becomes complex and dense enough, solar system formation can occur. Astronomers have predicted that the shockwaves caused by supernovae are vital to star formation. They believe that the large clouds of gas that escape from supernovae create new stars. While still a prediction, it holds a large amount of merit. The supernova theory states that every star, if large enough, will form a supernova once it dies. When recalling the star cycle, in which stars over 8 solar mass become red supergiants and then explode into supernovae once they die, this theory holds true. One piece of evidence supporting this claim was a surviving star from a stellar explosion in 1572 AD. This was observed by Pilar Ruiz Lapuente and her team. Alternatively, some people suggest that the radiation of a nearby supernova is what ended the Cretaceous period, a time period from over 100 million years ago. If a supernova was to occur near Earth, the radiation levels would be so high that it would destroy our ozone layer, removing protection from further outside radiation and ultimately ending all life on Earth. While plausible, there is little evidence other than this statement to confirm its validity. To conclude, supernovae are essential to life on Earth and the formation of solar systems. They are more than just an explosion symbolizing the collapse and death of a star. Rather, they are the synthesizer of most of our elements, some of which we may have not even discovered yet. It is essential to further research these phenomena to truly discover where we and the rest of the universe originated.
Thank you.